What is an example of reliability best practice in failure management? 1. Turn off monitoring. Have a backup and disaster recovery (DR) strategy. 3. Do root cause analysis to assign blame. 4. Turn it off and on again. An example of a reliability best practice in failure management is to have a backup and disaster recovery (DR) strategy. Why this is a reliability best practice? Proactive planning. Failure management isn't just about reacting to a failure, but also about preparing for it. Having a robust backup and DR strategy is a proactive measure that ensures your data and systems can be recovered in the event of a significant outage, data corruption, or disaster. Data integrity and availability. Backups protect your data, which is often the most critical asset. A DR strategy ensures that your entire system can be restored in another location so that you can continue to operate and meet business needs. Defining recovery objectives. A core part of this practice is defining your recovery point objective, RPO, the maximum acceptable amount of data loss, and your recovery time objective, RTO, the maximum acceptable downtime. These objectives guide the design and testing of your backup and DR plan. Regular testing. It's not enough to just have a plan. You must regularly test your recovery procedures to validate they work as expected. This process, often called a game day or DR drill, helps to identify and fix any issues before a real failure occurs. Why the other options are incorrect. Turn off monitoring. Monitoring is a critical component of reliability. It's how you detect failures and understand the health of your system. Turning it off would be the opposite of a best practice. Do root cause analysis to assign blame. While root cause analysis, RCA, is a best practice for failure management, its purpose is to learn from the failure and prevent it from happening again, not to assign blame. A culture of no blame is essential for encouraging honest and open communication during and after an incident. Turn it off and on again. While a simple restart can sometimes resolve minor issues, it is not a comprehensive or reliable strategy for managing failures in a complex distributed cloud environment. It doesn't address the underlying cause of the failure and can lead to a repeated outage. What are the areas of focus for the security pillar? Select 5. 1. Confidentiality and integrity of data. 2. How we handle change. 3. Who can do what with identity and access management. 4. Protecting systems with infrastructure protection. 5. Recovering from failure with change management. 6. Detecting security events with detective controls. 7. Responding to security events. The security pillar focuses on protecting information, systems, and assets. The following 5 areas are key to this pillar. Confidentiality and integrity of data. This area is about ensuring that data is protected from unauthorized access, confidentiality, and that it hasn't been tampered with or corrupted, integrity. This includes using techniques like encryption for data at rest and in transit, and implementing access controls. 2. Identity and access management. This focus area, often referred to as IAM, is about managing who has access to what resources and what they are allowed to do. It includes defining user roles, permissions, and authentication mechanisms to ensure only authorized users can perform specific actions. 3. Infrastructure protection. This involves protecting your systems and infrastructure from threats. This can include securing networks, operating systems, and applications. Strategies include using firewalls, intrusion detection systems, and applying security patches regularly. Or detective controls. This is about actively monitoring and detecting potential security threats or incidents. This includes using tools and processes to log and analyze system activity, such as security information and event management (SIEM) systems, to identify suspicious behavior or unauthorized access attempts. 5. Responding to security events. This area is crucial for handling security incidents effectively after they have been detected. It involves having a well-defined incident response plan that outlines the steps to take to contain, investigate, and recover from a security breach. This ensures a quick and effective response to minimize damage. What are the areas of focus for the sustainability pillar? The AWS Well-Architected Framework's sustainability pillar focuses on reducing the environmental impact of cloud workloads. It's built around several key areas. Understanding your impact. You can't improve what you don't measure. This area is about gaining an understanding of your current environmental footprint. This includes using tools to measure the carbon emissions of your cloud usage and analyzing metrics like resource utilization and energy consumption. By knowing your baseline, you can identify areas for improvement. Aligning to demand. This area focuses on designing your workloads to use resources efficiently by aligning them with actual demand. This means avoiding over-provisioning and idle resources. Best practices include using auto-scaling to automatically adjust resources based on traffic, and scheduling non-production environments to shut down when they're not needed. Optimizing hardware and services. This area is about making smart choices about the technology you use. This includes selecting energy-efficient hardware, such as newer generation processors, and leveraging managed services. Managed services, like serverless functions or databases, can often be more efficient because the cloud provider can optimize the underlying infrastructure. Data management. Data has a physical footprint. This area focuses on managing data to minimize its environmental impact. This involves implementing data lifecycle policies to delete or archive unneeded data, and classifying data to store it on the most appropriate, cost-effective, and energy-efficient storage tiers. Minimizing unnecessary data movement across networks also helps reduce energy consumption. Software and architecture. The way you design and write your code can have a significant environmental impact. This area involves optimizing software for efficiency. This can include using efficient programming languages, refactoring code to be more performant, and adopting event-driven architectures that only run code when triggered by a specific event. Process and culture. Sustainability isn't just about technology, it's a cultural shift. This area is about embedding sustainability into your organizational processes and culture. This involves educating teams, setting sustainability goals, and creating a continuous improvement loop where you measure, report, and act on your environmental footprint. Process and culture. It also includes adopting new, more efficient technologies as they become available. Which pillar focuses on the ability to use IT or computing resources efficiently? 1. Security. 2. Reliability. 3. Performance efficiency. 4. Cost optimization. 5. Operational excellence. The pillar that focuses on using IT or computing resources efficiently is performance efficiency. Performance efficiency. This pillar is all about making the most of your resources to meet system requirements. It involves selecting the right type and size of resources for your workload, and then continuously monitoring and optimizing them. The goal is to maximize performance while minimizing resource consumption. This can be achieved through serverless architectures, using services like AWS Lambda, where you only pay for compute time. Autoscaling. Automatically adjusting the number of resources to match demand. Efficient resource selection. Choosing the most appropriate instance types, storage, and databases for your specific needs. An effective performance efficiency strategy ensures your application runs smoothly, responds quickly, and scales appropriately as your needs change, without wasting resources. In a traditional environment, what would architects do? Select 3. 1. Guess how much architecture was needed. 2. Allow for evolutionary architectures. 3. Work with an architecture that was frozen in time. 4. Fear making significant architectural change. 5. Test system at production scale. In a traditional environment, architects would guess how much architecture was needed. Traditional environments often required significant upfront planning and capital expenditure. Architects had to make educated guesses about future needs, leading to over-provisioning or under-provisioning of resources, as it was difficult and expensive to scale later. Work with an architecture that was frozen in time. Once an architecture was designed and implemented, it was very rigid. Making a significant change to the fundamental structure was a massive, costly, and time-consuming undertaking. This meant that the architecture remained relatively static for long periods, regardless of evolving business needs. Fear making significant architectural change. The high cost, complexity, and risk associated with major architectural changes in traditional environments created a fear of change. Architects and IT leaders were reluctant to redesign systems, which could lead to technical debt and a lack of agility. What are the focus areas for performance efficiency pillar questions? Select 4 options from the list provided. 1. Selecting the right resource types for computing, storage, databases, and networking. Gracefully recovering from failure, ensuring systems remain operational during disruptions. 3. Reviewing your selection as AWS continues to innovate with new resource types and features. 4. Being aware of how your resources are performing through monitoring and analytics. Making architectural trade-offs can maximize your performance efficiency while balancing other factors. Ensuring confidentiality and integrity of data within your cloud infrastructure. Resource selection involves choosing the most appropriate types for computing, storage, databases, and networking based on your workload's requirements. Monitoring requires systems to collect and analyze performance metrics such as CPU utilization, network latency, and database throughput to identify bottlenecks. Reviewing your resource selection regularly ensures that you leverage the latest AWS innovations and maintain efficiency and cost-effectiveness. Making architectural trade-offs involves balancing performance with other factors like cost and reliability to optimize overall efficiency.